Today's video will demonstrate how the assignment operator and the swap function work with the standard template library's list class. Hello, I'm James Helfrich. Every container in the standard template library implements the assignment operator. This allows us to copy the contents from one container into another. But how does this work? The interesting thing about the list assignment operator is it demonstrates to the extreme lengths in which a standard template library goes to make sure that things are done as efficiently as possible. Well, let's see how that works. Let's see how the list works. We're going to start with two lists, list 1 and list 2, and I'm going to assign 2, 4, 6, 8 into list 1. This is going to use the assignment operator with the initialization list on the right-hand side. So now list 1 is going to have 2, 4, 6, 8, and list 2 will be empty. Now I'm going to move the contents of list 1 into list 2. Notice how list 1 is now empty, but list 2 assumes the value 2, 4, 6, and 8. Now I'm going to use the assign method to assign 3 x's into list 1. Then I'll use the assignment operator to copy the contents of list 1 into list 2. Notice how list 2 used to have 4 elements and now has 3. Now I'm going to use the initialization list constructor to create a vector with 2 elements, and I'm going to use the assign method to assign those elements from the vector into the list. Notice how I'm using the begin iterator and the end iterator. Now I'll use the initialization list with 1, 3, 5, 7, and 9, and I will assign the initialization list into list 2 using the assignment method. I can swap the contents of list 1 and list 2 using the swap method. I can also swap the elements of list 1 and 2 using a standalone swap function. Okay, so how does a copy assignment work? Now, it's easy to think that I could just clear the elements that were in the left-hand side, and then for every element on the right-hand side, push it back. Turns out it's a little more sophisticated than that. Let's see why. Let's go into Xcode and write some code. I have 2 lists. I have right-hand side and left-hand side are initially empty. Now notice these are lists of spies. Now a spy is a double that I created, which is going to keep track of how it is used. Specifically, it's going to want to keep track of how many times the copy constructor, the assignment operator, and the destructor are called. Now, when I say assign right-hand side on the left-hand side, then I expect the copy constructor, the assignment operator, and the destructor to not be called at all. On the other hand, if I put 3 elements in my right-hand side, and then I call the assignment operator, then I'm going to have the copy constructor get called 3 times. And we expect this because there were no elements in the left-hand side, and I'm going to copy 3 of them. Similarly, if I put 3 elements in my left-hand side, then I expect 3 destructors to get called. And sure enough, they are. Now, what would happen if I have 3 elements on my right-hand side and 3 elements on my left-hand side? Maybe you would expect 3 destructors to get called and 3 copy constructors to get called, but it turns out that's not what happens. What I get here is 3 assignment operators get called. In other words, we reuse the nodes that already exist. And then in fact, if I add a few more elements to my right-hand side, then I'm going to expect to have 3 assignment operators and 2 copy constructors because I got to create 2 new elements. Now, let's do the same thing, except now I'm going to have a couple extra elements in my left-hand side. I expect to have 3 assignment operators and 2 destructors. Let's see if that's true. And there we go, 3 assignment operators and 2 destructors. So clearly this pseudocode of the copy assignment operator is a little oversimplistic. Let's take a look what actually happens. First of all, if the right-hand side and the left-hand side both have nodes, I want to copy the values using the assignment operator from the right-hand side onto the existing nodes in the left-hand side. Now, if the right-hand side has more nodes than the left-hand side, then I want to push the extra nodes onto the left-hand side. But if the left-hand side has more nodes than the right-hand side, I want to delete the extra nodes. So let's take a look at case 1 here. First of all, I'm going to have an iterator through the right-hand side, and then I'm going to have an iterator through the left-hand side. And while both these iterators are not empty, then I'm going to copy the value over using the T's assignment operator. In this case, it would be my spies assignment operator. And then I'll increment both iterators. So we'll start by assigning the right-hand side iterator to the beginning and the left-hand side iterator to the beginning. And then while the right-hand side and the left-hand side both are not the null iterator, then I will copy the value over. So 3 will go on top of 10, and then I'll advance both iterators. From here, I go back. Both iterators are not null. I will copy the value over. So 4 goes on to 20, and then I'll advance both iterators. Now, once again, I'm going to copy 5 onto 30, and I'm going to advance both iterators. Now, at this point in time, it's no longer true that both the left-hand side and the right-hand side iterators are referring to real elements because the right-hand side is end. So at this point in time, I will stop with this phase. Step 2 is when I have extra nodes to be added. In this case, the right-hand side has more nodes than the left-hand side. So I'll start with my iterator already in the middle of the right-hand side. And why is that? Because I already did the initial loop from step 1, and I've copied several values over from the right-hand side to the left-hand side. But now right-hand side has extra nodes. So first of all, my right-hand side iterator is not the end. And so while it's not the end, I'm going to push back this value. So now 44 will get put into a new node, and it get added onto the end of left-hand side. Then I'll advance my right-hand side iterator, and then it's not the null iterator, so I will push back 55, advance the node, and then once again, I am not the end iterator. I will create a new node, and then I will advance the iterator, and at this point in time, I'm off the end. So I exit the loop. Step 3 is when the right-hand side has less nodes than the left-hand side, in which case I have got to remove the extra nodes. And once again, the iterator is always going to be in the middle here. And that's because I've already copied over the nodes where the right-hand side and the left-hand side have in common. So my left-hand side is not null because I still have nodes left. So while the right-hand side list is less than the left-hand side list, then I'm going to pop back. And it's going to remove the 60, and then I'll remove the 50, and then I'll remove the 40. At this point inside, both the left-hand side and the right-hand side are the same size, and I'm finished. We can learn more about the assignment operator in the assignment section of the list chapter of the C++ data structures textbook.